Hello friends, today this is the fourth session of computer numerical control. In the last video we have discussed about introduction to programming commands, so everything. So today we will go further a few points based on the same thing. So today we will be discussing use of G codes, that is G01, 02, 03 commands. So calculating table feed, cutting speed, feed rate, material removal rate, power consumption for milling, and drilling operations on vertical milling machines. So these all topics will be discussed today. So now let us go for seeing how we can use G codes here. So here you can see we have a diagram. uh, just a second. Yeah, so what we have here is just you can see, so this is the arrow black in black diagram. So what we have, okay, so what we have in black, so what we have in black, so this one, okay, so this is nothing but a diagram, a shape what we have taken, okay. So that is the shape what we have taken. So for that we need to write the program to cut that one, okay, a milling operation. So now the S point, okay, so this is the S point, so this is S point where it starts, okay, the origin what we have considered. Next next point is this one, okay, so this is the next point which has the coordinates as 50 0. Okay, now to travel from point S to next point, that is 50 0, linear interpolation, okay, so this is the way how it has to travel. So there is a linear interpolation, okay, so this is the way how it has to travel. So that is linear interpolation what we have. So that is being given as Z01, okay. So Z01 coordinates we will give x axis it is 50 mm. So here you can see x axis it is 50 mm and y axis it is 0. So Z01 x 50 x50 y0, this is how the program will be written, okay. When it go for the next step, so this one it is again a linear interpolation. So G01 again 50 x50 y20, because y it is again 20. So this one you can see, so x50 y20. Again here now a new thing what we are going to learn, it is a curved shape, okay, that is in arc, it has to go in arc, and in which direction it is, the interpolation, circular interpolation, clockwise or counterclockwise, that is what we need to take care, okay. So now it is clockwise, okay, G02 it is nothing but clockwise direction, G03 is anti-clockwise direction, okay. So G02, so it is moving, okay, so you can see it is moving like this, okay, like this it is going. So it is G02 in a clockwise direction. So G02 x-axis we are giving these coordinates, x-axis 25, that is it reduces, okay, why 25, because this is 50. Again this is from origin, always we are giving the coordinates with respect to origin, absolute coordinate system, okay. So x 25 or and y 45. So like this it will go on. Now from this point, okay, from this point to this point, so what all the path it travels here, again it is a curve shape, okay. Now in it is a curve shape, but in which direction, clockwise or anti-clockwise, you can observe. Now this traveling, okay, is anti-clockwise direction, so we are going for using G03 next coordinates, that is, now this is origin, so hence this point, okay, this is S is origin, and hence this point, okay, so this point is nothing but we are the coordinates for that point is minus 25, x axis minus 25 and y axis 45. So like this we are going for writing the coordinates, that is G03 x minus 25 y 45, that is what we get this point, okay. So next comes from that point to next point is this. So it is again clockwise, we have a circular motion, so clockwise direction. So again it comes as Z02 next coordinates, so these are the coordinates minus 50 20. So next point again the same thing, linear interpolation is there, that is Z001. So then points are x minus 50 y 0, okay. Again it has to come back to the origin Z01 x0 y0. So when we write like this the program, so totally our tool will follow this path and it will come back to the origin. Got it? So this is how it goes. Now you can see, okay. So next, here the actual program, how it is being written was step by step we have explained here, we can see. Okay, so first, program number, any of the program number with respect to the company, what codes they give for that one, that program number will be given for it according to their standards. Next is N01 G21. N01 is a serial number, I mean how we give it, N01 02 03 numbering what we are giving. Then G21 is nothing but metric units. Okay, metric programming, so we are going for metric units here. Next is N02 M03 S1000. M03 is nothing but what? Spindle start and in clockwise direction. S is nothing but speed. Okay, it is 1000. This one. So N02 M03. Okay, that is what we have. Next comes this one, next third row, N03 G00 X0 Y0, rapid motion. Z00 is nothing but rapid motion, point to point motion. My spindle will come there and stop at Z00 X0 Y0, that is S point. So this is S point. Okay, next ZN, next line, N04 G01, linear interpolation. Okay, Z minus 10, Z axis. Z axis is a vertical motion. X axis, Y axis, as we have here, X axis, Y axis. Vertical up and down of the spindle is nothing but the Z axis. So Z minus 10 is nothing but it will go down. Okay, minus 10 mm, it will go down and stop there. Okay, so move in 10 mm towards Z, it will go down. Now the milling will start actually. N05, that is serial number, G01 linear interpolation, X50. So Y axis, when it is 0, so commonly we can exempt it. So only which values are there, so that one we keep it. Okay, and it will be remembering the previous value. Now previous value is Y0. Here you can see Y0. So the same thing will be continued if you won't give that one there. Okay, so now G01 X50. Similarly, N06 G01 X50 Y20, next point. So this point. Okay, so like this what we have going to do. So we will go for the next slide. Same thing. Okay, just now what we have discussed, the same thing we have here. So we have N sorry, yeah, let me remove this pointings. We will go with the numbers. I will say the numbers. Observe that line. So N08 Z02, that is circular Z02. Just now before we discussed the same thing, same ways we are going for writing the program here. N8 N9 N10 N11 N12 N13. Okay, so N12 till N12, that is what we have discussed. Z01, we will come back to the origin. Next is N13. Okay, let me take here the highlighter, that will be very understanding for you. Yeah, N13. Okay, what we have the N13. So now here you can see N13 Z00 Z10. It is nothing but Z00 rapid motion. Z10, we will take the spindle up here. Okay, Z10 in Z axis. Okay, till now the spindle was down and it was cutting the workpiece. Now when it is stopped at the origin, okay, here this is N12, though it is at the origin. Now we will take it up. The spindle will be moved up. Then last line, that is M05 M30, spindle stop. M05 is spindle stop, M30 is end of the program. So this is how the program is being written. Okay, this is how we go for writing a program for milling operation. Okay, I hope you understood this one. So let us move the next. Similarly, just okay, we have it. Then okay, this is this is what we discussed about the programming, how we write the programming. Next, what we have is formulas for milling operation using milling cutter. So we have a few formulas what we are going for using here. I mean to calculate a few of the parameters. Now you can see table feed. Okay, how much it has to be given. VF, that is been given as VF, that is equal to FZ into N into ZE FF. Okay, here what we have is FZ is nothing but feed per tooth. Okay, N spindle speed, ZEF number of effective tooth. Okay, with based on that how much table feed has to be given will be decided. Then cutting speed, similarly we have the equations for everything. Pi into DCAP into N divided by 1000. Okay, this is what we have the equation. VC is equal to pi into DCAP into N into 1000. So what we mean here, decap means so cutter diameter at cutting depth. Okay, diameter. N is spindle speed, based on which we go for calculating cutting speed, how much it has to be for that tool. Okay, so next is spindle speed. Similarly, N is equal to VC into the same thing, it is been rearranged. Okay, so then feed per tooth, how much it has to be, that we can calculate using this equation. Feed per revolution, these are just for your information. It is not much there in the syllabus what all the formulas we are showing. It is just for your information. Feed per revolution, Fn is equal to Vf divided by N, that is nothing but feed per revolution divided by N. Okay, feed is Vf, commonly before we have discussed that equation, then divided by N, spindle speed. Okay, then metal removal rate Q. Okay, AP cutting depth into working engagement, that is AE into VF. Okay, that is you can see here AP cutting depth, AE working engagement, and VF table feed. Okay, that is what we get the metal removal rate. Okay, so like this what we have few of the equations which are useful for calculating milling operations and all. That's it what we have for today. Hope all of you understood. The few of the things which are remaining we will discuss it in next video. Thank you.